students and educators and general public all across the United States.
Yes, that's correct. And one thing I wanted to get across is one thing that we do in all of our workshops are online. We give free professional development webinars. We do 4 a week monthly, and they're all aligned to the next generation science standards. And that's a big push in a lot of states is integrating those. And so we really try to stay up to date with the newest standards. We also, with our free online webinars, we also have a website where teachers can go and sign up for these. It's free. And so I was going to go ahead and give you the website. It's www.txstate-epdc.net. So that's where you can go, and if you click on events at the top, you can see the list of all the webinars for the month of upcoming October.
And these are various webinars, all free, all online. Anybody can register. And it's not just you that are doing these webinars, correct?
No, so there's 10 of us, educated professional development specialists, and we're located at each of the 10 NASA centers all across the United States. So whether you're in the Ames region or you're in Texas or Huntsville, there's a specialist there to help you out. And you can go to the website, you can find our information, and you can sign up for face-to-face workshops. You can request those, and you can also sign up for our free online webinars.
Free online webinars, excellent for educators and students, especially people who are in various STEM degrees and STEM fields. And so you just mentioned going and doing some lunar certification workshops, and so you'll be traveling to do that. Tell us a little bit about how these workshops go. We're talking all sorts of lunar content tonight. What's some of the coolest things that you are teaching people about the moon?
So one of the cool things that I enjoy teaching when I'm teaching about the moon is talking about the different types of rocks that we find on the moon. And so we do this one activity, and it's called rock card sorting. And so I talk about the northosite rocks, the impact breccia, and the I'm drawing a blank. There's 3 different kinds that we talk about. And I talk about which part of the moon that they're located on. And then the teachers actually get rock cards, just like the planetary geologists get, and they actually have to look at the rock and identify which kind it is, just like they would in the lunar lab. And it just really relates to what scientists do, and that gives the teacher an idea of how they can integrate it into their classroom with their students.
That sounds like a lot of fun. It's a very interesting activity, and something that you can not only enjoy, but also can kind of share that with other people. And so I know that's one thing, is that if you get a chance to reach out and teach 20 educators, then those 20 educators in turn reach out and teach 200-300 students, and then the cycle of life continues.
That is the goal, is we want to reach not only teachers but students as well.
And so while we have you online here, we're showing live feed. We've been showing live feeds all night tonight. Some have been crisp and clear, and others have been very cloudy. We're seeing a feed right now from the Lafayette Science Museum in Lafayette, Louisiana, and who through all night was experiencing heavy clouds. And fortunately, we were able to actually get some clear view skies of what's going on here. So real quick, Mitzi, while we got Maria Chambers on hold, can you give our viewers a description of what people in Lafayette are experiencing and what our viewers across the globe are able to see with tonight's total lunar eclipse?
According to my table, the total eclipse ends, or ended, at 10:23 p.m. Central Daylight Time. And if you see just on the left side of the moon, in this image that we're receiving from Lafayette Science Museum, it's getting brighter and brighter. So the moon is moving out of the umbral, the darkest part of the shadow that the Earth is casting on the moon, and the total eclipse phase is ending.
This is a great feed. And so Maria, you're out on the West Coast. You're getting a chance to see the feed when it see the total lunar eclipse when it happens on the West Coast. And so what are some activities that you use to teach people about solar eclipses and about lunar eclipses?
So, with the lunar certifications, we don't actually focus specifically on the lunar and solar eclipse. We talk more about the impact craters and how the moon was formed, those aspects.
Okay, and on our live feed, we can see as the as the moon is being revealed, as it ends and is going out of phase, we can see some of these craters on the moon, large craters, basalt-filled Maria. And so can you give us a little description of what are some of the geological features that we find on the moon?
Some of the geological features?
Yes.
So, well, we have various sizes of craters, and like I spoke of earlier, we do have different rock samples that we have found. Specifically, we have the volcanism where the volcanoes erupted, and so that left different rock samples also. And that's one thing that we share in our workshops is we have samples of those rocks, and the teachers get to see those and look at them under a microscope up close. And you know, it really brings it to life for them and brings it to life for their students, and they're able to bring it into the classroom for those 2 weeks.
That's a great way to put it. It brings it to life. Everybody gets to see up close and personal, literally through telescopes. And so, real quickly, before I let you go, can you give us the Twitter account that people can follow to learn more about your educational webinars?
Yes, so our Twitter account is at NASA EPDC, and we have a Facebook and Twitter account, and so you can follow us there and get up-to-date information on all our webinars and then upcoming face-to-face workshops as well.
EPDC, so it's at NASA EPDC, and that stands for Educator
Professional Development Collaborative.
Collaborative, okay. I wasn't sure what the last letter was. So. At NASA EPDC is the Twitter handle that all our viewers across the world can follow to learn a little more about the work that you do as well as all your colleagues. Maria, once again, a good friend of mine I've known for several years, and I really appreciate you taking the time to talk lunar education with us.
Thank you so much.
Thanks, Maria. Talk to you soon.
All right, bye.
Bye-bye. Maria Chambers works at NASA Ames Research Center in just south of San Francisco, California. And so they're getting a chance to experience the eclipse, whereas here on sort of the East Coast, we're in Central Time, but we're close to the East Coast, kind of mid-America. We're seeing a feed from the Lafayette Science Museum as the eclipse is ending. And Mitzi, is there a term, if we're talking about the phases of the moon, waxing and waning, and we're talking about the eclipse entering the penumbra and umbra, is there a term that we use for that would be similar to waxing and waning for solar eclipses? Or lunar eclipses?
Not that I'm aware.
I've never heard one.
Basically, the shadow is more or less symmetric. So the phases that we go through at the beginning of the eclipse are just repeated at the end of the eclipse.
Right. Yeah. Mostly I see it referred to as entering the penumbra or umbra. Entering or exiting seems to be the main description. But you never know. There could have been a key term that you scientists know. So I really appreciate that. And appreciate everyone who's joined us all night tonight. Excuse me, as we have had a great audience. Great is an underestimate. It's been overwhelming. In fact, as we've showed our feeds tonight, all night tonight, we had over 200,000 people try to log on to nasa.gov all at the same time. This caused a little bit of a network issue. That wasn't quite on our end. It was on the providers and ISP providers and all that. And so there were already, a countless number of people who are on nasa.gov, and then over 200,000 people try to log on following that, and just floods the network. In fact, it was told it was one of the largest spike that they've had since space shuttle days. And so well over 1 million people, I've heard, have been logged on throughout the night, both on NASA Marshall Ustream as well as NASA Marshall Ustream account. And so that is a true testament to just how interesting people or how interested people are into these kind of lunar eclipses.
I just thank everyone for their interest in science, and keep it up.
Yeah, absolutely. All around the world, a long list of countries. I've been rattling the names off as we scroll through our Twitter feed. And so if you've got questions, you can continue to ask your questions to at NASA_Marshall. That's our Twitter account, at NASA_Marshall. You can use the hashtag AskNASA. We've got a staff that's here in the studio, and we're answering questions and liking and faving and sharing as many as possible. You can also get involved in our photo contest tonight. You can take a picture of the eclipse and you can submit it if you go to our NASA Marshall Facebook page. Go to NASA Marshall Facebook page, as well as a couple other pages. You can go to NASA Goddard Space Flight Center. You can go to their Facebook page. You can go to the main agency NASA Facebook page, and you'll find a tab across the top of the screen that will say hashtag SuperbloodMoon. That's the hashtag for you to tag your lunar eclipse photo, and we're going to go through. We got a staff in there right now. I've been going through and scrolling, seeing the photos of that our staff is going through and selecting. Literally hundreds and hundreds and hundreds of photos. So we're going to pick the best ones, put them on a gallery, and let you, the viewer at home, take a chance to vote on your favorite ones, and then we'll take the best image or the best top 5 or top 6, and we're going to put those on NASA's social media accounts for the world to see. So very excited to have that social media engagement and to see all the people around the world that are talking and just asking questions. Mitzi, it's such a great age we live in where we can bring people from all around the world together.
I think so, and this eclipse is really special because Canada and the United States and Mexico and all the countries in Central America and South America, we're all getting an opportunity to see this eclipse at the same time, assuming we have clear skies. But even if we have cloudy skies, everybody is focused, or a lot of people are focused on looking at the sky and learning more about our closest neighbor in space, and I think that's a great thing. I'd really like to thank all of our participants here, Austin P University in Clarksville, Tennessee, Fernbank Science Center in Atlanta, Lafayette Science Museum in Lafayette, Louisiana, are currently providing us this live feed. We have been getting some images from the University of New Mexico in Albuquerque, and I'd really like to thank the folks out there for trying to put this together. At the moment we don't have those up, but we're trying to get them up. John McGraw and Don Zierzow and Pete Zimmer and some students out there have been really helpful in putting that together. And if we don't get it together before our show is over tonight, we will have those up later, and especially after we edit the movies.
Absolutely.
But we have so many people participating in this event and asking questions, and I'm really happy that we're able to answer as many as we have. And again, please do submit those questions if you have them, and keep looking up.
Absolutely. We've got great questions coming in. While we wait for our next guest to join us on the line, I'll go through and pull a couple questions right here. This one, I like this one, and this ties into a fun fact I came across a few weeks ago. So this one is from _Letitia Rose. Mitzi, this one's an easy one. I think a lot of people are seeing this is a great educational opportunity because they're seeing these words. And so why do we call this a supermoon?
Okay. The term supermoon simply refers to the fact that the moon is at its closest point in its orbit around Earth. And we call that perigee. And the point in its orbit where it's farthest from Earth is called apogee. And similarly, we have a similar term for when Earth is closest to the Sun, and that would be called perihelion, and farthest would be aphelion. And there's not a whole lot of difference because the orbits of Earth around the Sun and the Moon around Earth, they are in fact elliptical, but the ellipses are very close to circular. So the difference is not that great, but we do call this a supermoon because it is its closest approach to Earth in its orbit. And it also happens to be a harvest moon, which is kind of interesting.
Yeah, very rare.
I wouldn't say it's rare per se, but it's kind of interesting because the moons, each moon, every month, there's a name for the moon. We're most familiar with the term harvest moon, but there are other names that have been coined throughout time.
Absolutely, and it changes whether it's blood moon or supermoon, and it's all based on just kind of the society and culture. We talked a lot with one of the earlier experts about archaeoastronomy, and the way the Mayans and the Incans would have viewed it, and the way they would have phrased it and thought about it is obviously a little different than today. And so human history definitely changes some aspects. And so the supermoon is cool. So would it be true that when the moon is at apogee, when it's further away, we would call that a mini moon? Could we go for that?
We could go for that, yeah.
Supermoon and mini moon. It's just if it's closer or farther away. And so We are joined by one of our guests, a very special guest joining us. I believe we have him on the phone right now. Mitzi, I'll let you toss and see if you can get our special guest on the phone.
Hi, Mitzi.
Hi, Jay. Great to hear from you. This is Dr. Jay Pasikoff. He is extremely well known for solar eclipse observations. He's a professor at Williams College, and we have a couple of questions for you.
Sure. We've been having a lot of fun here in Williamstown, Massachusetts, watching the eclipse for the last couple of hours.
Well, I understand Boston is clear, and you're clear as well.
Yes, there have been a few clouds drifting over, but we're about 135 miles west of Boston, near the New York state line, and it's been almost entirely clear. And then it got nice and dark when the moon went away, and we could see the Milky Way, and we see the Pleiades rising. It's been fun. We had about 100 people. Some of my students from freshman courses and other students have been up.
Well, that's fantastic. I'm glad that you had a good experience. I haven't, but I have been enjoying the feed from Lafayette.
Was it cloudy down with you?
It's very cloudy.
Oh, I'm sorry.
Not even a glimmer. I should have flown out to New Mexico, where John McGraw is. Why do eclipses, both lunar and solar, fascinate you personally?
Well, I started off with a solar eclipse my freshman year in college when my professor flew his freshman seminar up in a plane to see the eclipse, and just the idea that it can be predicted and the dazzling darkness just really enthralled me, and I've now seen 62 solar eclipses. The lunar eclipses are just kind of fun. You can practice some photography, you can look up, see the moon turn red, know that things are being predicted right, and it's kind of a holiday thing for me, because the tension of a minute or two or three from a solar eclipse is absent when you get this hour-long totality.
Yeah, it's quite a treat to have so much time to set up your camera and take photographs, whereas in a solar eclipse, by that time it's all over.
Yes, but we do try to get things very accurate. I know you and I have discussed, Mitzi, getting accurate information out to the people for the 2017 August 21st solar eclipse, which will be great with the path of totality crossing the country from Oregon to South Carolina. So we want people to know how to observe it and why it's fun to observe, and that you can see the total part without any filters, but that you need filters for the partial phases as you're off to the side or before and after. But for this lunar eclipse, it's just been very annoying that there's been this so-called blood moon, which of course is really a silly name. I'd like to call it a raspberry sherbet moon. It's just a little faint reddish that's there in the sun all the time, but usually hidden behind the bright white, I'd say French vanilla sunlight hitting the moon. So as soon as about a third or half the dark part of the moon became visible, you could see a little reddish raspberry sherbet there. So we've had fun looking at that.
I'm fine with that.
Raspberry sherbet. I'm a runner, Jay. So yesterday I ran 14 miles and I'm still hungry. So you're making me hungry again.
Okay.
So, how are you seeing the eclipse? You describe it as raspberry sherbet. Does it appear any darker, or is it any more red than perhaps the last one that you saw?
Well, it's hard to know. I saw the eclipse in April, the lunar eclipse in April, and it's hard for me to really compare without seeing side-by-side photographs. This might be a little less red. Maybe the volcano in Sumatra a couple of weeks ago did something to particles in the air, but it's hard to say. You really see the red better with a long exposure on my Nikon, and it's just fun to think that that's the light from sunrises and sunsets all around the world leaking through and hitting the moon.
So where do you plan to be on August 21st, 2017, which is the date of the total solar eclipse that will go all the way across the United States?
Well, I've looked at the weather statistics, the cloudiness statistics that the meteorologist Jay Anderson compiles from satellite photographs over about 20 years, and it looks to me that Oregon has the best chance of clear weather. My wife and I did go out there a year ago, and sometimes it was clear, and sometimes it was cloudy, and sometimes it was partly clear and partly cloudy. But going by the statistics, I like to go by the statistics, and that's where we're going to go. I have a group of tourists who will accompany my professional group of researchers, and we're looking forward to that.
Well, I know that you have had students go with you in the past.
Yeah, we always take our Williams College students.
And about how many do you suspect you'll have in 2017? Is it kind of a standard number, or?
Well, these are undergraduates, so we don't really know in advance. I'll give my seminar for juniors and seniors on solar physics that semester, and so maybe we'll be able to take all the students in the seminar, but I don't know how many that'll be.
We are observing a lunar eclipse here, but I'm going to ask you a question about solar eclipses. You are well known for doing scientific observations of solar eclipses, and I've heard it said that with all of our observatories in space, using the solar eclipse to do science is not as important as it used to be. How do you respond to that?
Well, it's not the only thing for studying the corona now, but there still are large gaps in the coverage of the sun from space that we can still do best from solar eclipses. So there still is at least a decade or two of important research that you can do with a solar eclipse. For one thing, the European Space Agency spacecraft that makes a coronagraph in space, that makes an artificial eclipse, starts a whole solar radius out above the edge of the sun, the limb of the sun. So there's a whole donut of region around the sun that they can't observe from space. There are some other spacecraft, NASA's Solar Dynamics Observatory, for example, that uses ultraviolet filters, as you well know, to look right at the middle of the sun, the standard disk of the sun. But between those boundaries, there's a whole region where the solar wind is formed and important things happen that we can see best from space. Also, our resolution in the middle and outer corona is better than those from the spacecraft. That's just the way the spacecraft was designed. In fact, the designer of the instrument, the coronagraph, was with me at an eclipse in Bolivia 20 years ago, and he said he would have designed his instrument with higher resolution if he'd ever seen an eclipse before. He didn't realize there was so much important detail to see. So there's still a lot that we can do from an eclipse that you just can't do from space, and we can complete the picture of the sun on the days of eclipses only by doing both the eclipse observations and the space observations.
And you do try to combine the observations that you make during the eclipse with those from space at that particular time, is that right?
Yes. So, for example, a few days after the eclipse in 2013, a combination of my eclipse view with some space views outside and inside the eclipse view was an astronomy picture of the day. You can look that up for November 11th, 2013, for example.
I kind of asked you this in passing when we were discussing eclipses, and I asked you which one was your favorite.
I didn't give you an answer, did I? I like them all. Each one is good. I've got good memories of each one, and each is different, and different circumstances, different last-minute problems, different excitements, and of course, scientifically, the corona looks different each time. I've seen 31 total eclipses out of the 62 solar eclipses of all kinds, and some are with solar maximum, and some with solar minimum, with different shapes of the corona, and sometimes there are coronal eruptions that go out there. Each one is different, and they're all good.
The thing that amazed me, the first